In this recording, we're going to solve quadratics algebraically by taking square roots. So far we looked at graphing, looked at factoring. Now we're going to make a connection with square roots. Square roots, frankly, is not that useful a technique all the time. It's just useful under particular circumstances. And we're going to find out what those circumstances are. What are the limitations? What are the ways in which it's set up well? So the first part is, well, what happens when we square root a square? Why does it really equal the absolute value of x? It doesn't just equal x. Well, let's take a look at the graphs and the tables from each side of this equation. So go into your graphing calculator, or just watching with me if you don't have one. Let's graph the square root of x squared. It's important that we do it in that order, the square root of x squared. So notice how you can square a negative and you can square a positive, and either way you're going to get a positive, right? When you square root that positive, you're always going to get a positive. So you're going to get the principal root. When we look at the graph, let's go zoom 6, get a standard graphing window. You can see, you recognize that shape, right? That's our absolute value graph, and we can confirm that by looking at our table. So second, and then the graph button. In the table, we see that yes, in fact, you don't see any negatives here. It is taking the absolute value of all our x values, right? That's the distance from 0. That's our definition of absolute value. Distance from 0 for all those negatives and positives is a positive. Great. So in terms of the table and the graph, we can just kind of take some screenshots here and paste those into our notes. All right, so write something down in your notes. You've got the square root of x squared as a function, y as a function of x, and it makes this graph, which is really the absolute value, and it produces this table, which we obviously can see as the absolute value. So have all three of those pieces in your notes. Now let's use that information to do some solves. So it says solve each of these equations by square roots. I think you know what to do here, but let's just do a hand-holding example at first. So we want to get x by itself, but it's got this square, so let's square root both sides. And of course, this produces not x, but the absolute value of x. And that's equal to 13. So that's equal to, well, what's a number that could solve this? Well, certainly 13 is a value, but so is negative 13. So we're going to express it as x equals plus or minus 13. All right. When you get to the next one, we got to do a little work to get x by itself, and then square root. So why don't you do that one, and why don't you work on c first as the second step. Do a little work to get x squared alone, and then square root. So play the recording when you're ready to check your answers. All right, so hopefully you divided both sides by a -2 first to give us 25. Now we can square root both sides, and when we do so, we get the absolute value of x is equal to 5, which means that x is equal to the plus or minus 5. Working on this one, when we subtract 14 from both sides, we get a 9. Square rooting both sides, we get that the absolute value of x is equal to 3. So x is equal to both the positive and negative value of 3. And you can just check that. I mean, if you subbed in -3, squared it, that would be 9. Add 14, yeah, it would check out. Finally, when is it appropriate? What are its limitations? So it works when the value of b, the coefficient of x, is 0. It doesn't work very well any other times. Next, let's solve this by factoring and by square roots. Why don't you do as much as you can and then play the recording when you've got it. All right, so we'll kind of cruise through this. You can just use this as a checking, or you can play it as slow as you need to get feedback. So factoring and root. So for factoring, I want to get all the terms on the left side. I want to get it into what's called standard form. So I'm going to subtract 29, and I get minus 36. We said anytime we have factoring, we want to take out a GCF first. I have a 4 here. Okay. Go ahead and finish this out. So finally we have the two roots, 3 and negative 3. Notice here that 4, while a factor of this expression, cannot equal 0, so it does not contribute to the solution of this expression, of the equation, excuse me. Now let's work it out by square roots. Now square roots, we do not want a 0 on the right side. In fact, we want to get x squared by itself, so we're going to get rid of this negative 7 first. So do as much as you can with that, and then play the recording for some feedback. So x is equal to plus or minus 3. Well, because they were the same equation. Hope they're the same, right? Finally, can you solve this by square roots? Well, it's kind of a funky setup. I suppose we could. I mean, this expression here, this x plus 3, we could isolate by square rooting to get rid of the square. Of course, that would give me the absolute value of x plus 3. On the right side, we just have a 5. What do we do with this? Well, we know that the x plus 3 could equal two things. It could equal 5, or x plus 3 could equal negative 5. And I'm splitting it up into two equations here just to make it easier to solve. So on this side, x equals 2, and on this side, x equals negative 8. Those are our two solutions. Thanks for watching.